All right, section 9.5 is about graphing primarily piecewise functions, and I am going to go ahead and define the greatest integer function. We're not going to see that a lot, but it's good for us to define it. So first introduction to this, before we get into how to graph piecewise functions, is we're going to go over every single function we've already talked about in this class, starting with our constant function, right? This is a function of the form f of x equals c, where c is a real number. This is a function because it passes the vertical line test. Its domain is all real numbers, and its range is the only value, y value it takes on, which would be whatever constant it's equal to. So for example, this looks like the line y equals 3/2. That's what I think this is. Next, we have our identity function. This is our simplest line function. It has a positive slope. We have f of x equals x. It's a degree 1 polynomial, or like I said, it's a linear equation because its graph is a line. And its domain is from negative infinity to positive infinity, and its range is from negative infinity to positive infinity. So this is for any sloped line, as long as it's not zero slope, because that's what we just saw, the constant function. Next, we have the absolute value function. Remember, when we take the absolute value, what we're doing is we're measuring the distance from the origin. So I have f of x equals the absolute value of x. This is a function where the output represents the distance to the origin on a number line. So like the absolute value of -2 is 2. The absolute value of 2 is 2. So it's matching each x value with its absolute value. Its domain is all real numbers because you can take the absolute value of every number, but its range only goes from 0 to infinity inclusive, because the absolute value of 0 is indeed 0. Next, what we've been working with most recently is our parabolas, right? Otherwise known as our square function. This is the function f of x is x squared, and it's obtained by squaring every value of the domain. Its domain is all real numbers, but its range only goes from 0 to infinity. And remember, we can shift this around our graph using vertical and horizontal translations, like we learned at the beginning of this chapter. Then we've got our cube function, right? F of x equals x cubed raises all values in the domain to their third power. And the result can be either positive, 0, or negative, right? Because -2 cubed is -8. 0 cubed is 0, and 2 cubed is a positive 8. So its domain is from negative infinity to positive infinity, as well as its range is from negative infinity to positive infinity. And one thing I want us to keep in mind, that this function is continuous over its entire domain. Again, in this class, it means that I can draw a picture of it without picking up my pencil. We also have the square root function, right? We talked about radicals in chapter 7. So if I have f of x equals the square root of x, its domain is going to be from 0 to infinity, because I can't graph complex numbers. Even though I can find them, I can't graph complex numbers on a real number line. So the smallest value in the domain is 0, as well as the smallest value in our range is going to be 0. We also have the cube root function. This is a little messy. Sorry, I'll fix this. But the cube root function is f of x equals the cube root of x. So we're going to take the cube root of every single number, and I can take the cube root of negative numbers, positive numbers, and 0. So its domain is all real numbers, as well as its range is all real numbers. Next, we have the reciprocal function. This is a rational function. This is defined as f of x equals 1 over x. And it only has one restriction on the domain, and that's that x can't equal 0. And because so our domain would be all real numbers except when x is 0. And because the denominator is of higher degree than the numerator, we have an asymptote at y equals 0. So our range also cannot include the value 0. next I'm going to introduce the greatest integer function. There'll be one problem about this on your homework. So the greatest integer function, denoted f of x equals double bracket x, assigns the greatest integer less than or equal to any number in its domain. So for example, 5 would graph to 5 because 5 is less than or equal to 5. -2 would graph to -2. 0 would graph to 0, right? So whole numbers map to themselves. It gets tricky when I don't have a whole number. So for example, if I have 6.45, that's going to graph to the integer less than it, which would be 6. 3.7, we're going to send that down, right? 3.7 would have been like up here. We're going to graph that to 3. And with negatives, it gets a little trickier because -1.7, it has to be less than. It wouldn't graph to -1. It goes down to -2, as well as -1.2 would also go down to -2. So that is the greatest integer function.